In this section, we're going to learn about direct variation and proportions. And I'm going to show you a formula to use for direct variation. And it's nice to use this same formula every time you solve a problem and follow the 3 steps that go along with using the formula. And the formula for a direct variation is y equals mx. Y varies directly as x. Y varies directly as x. But there's a constant of proportionality that tells you how x changes based on y. So let's use this formula and plug in the values. So y varies directly as x, and y equals 25 when x equals 15. So I take that. First step is write the equation. So equation. The second step, solve for m. So if I solve for m here, I get m equals 25 over 15, which of course reduces to 5 over 3. So there's our m. And the next step is to write a new equation using m. Use m. So now that I have the m, I can plug that into the equation and finish solving to get the rest of the information. So here's our original equation, but now I have an m, so I say y equals 5/3 x. We have the m. Now go back to the original equation. Find x when y is 40. So let's just put the 40 in here. 40 equals 5/3 x. Let's solve this. Multiply both sides by what? I hope you said reciprocal. So 3/5 times 40 equals 3/5 times 5/3 x. That cancels out. 5 into 40 is 8. 3 times 8, x equals 24. Can you see that? Oops, I guess I better write it up here. X equals 24. So, there we go. Let's try one more. If a is directly proportional to b to the third. Now this one used x's and y's. Now I'm going to use a's and b's, but I'm going to write a very similar equation. A is, so a equals directly proportional to b to the third, and directly proportional means there's some constant of proportionality. So there's my m again. Now go to the information you have and solve for m. 10 equals m times 2 to the third. Hopefully you know 2 to the third is 8. So 10 equals m times 8. Divide both sides by 8. You with me there? All right. Let's reduce. So that would be 5/4 equals m. What do I do now? I had my equation. I solved for my m. New equation. So go back here to this equation. We know the m for that now. A equals 5/4 b to the third. There's my better equation. I can use that to solve for the rest of this problem here. Oh, I erased that. When b equals 4 we're supposed to have there. So find a when b equals 4. So find a when b is 4. So a equals 5/4 times 4 to the third. So a equals, let's reduce here before we multiply, make that 4 squared. So 4 squared is 16, 5 times 16, 80. So a is 80. So again, these problems, first equation, pretty straightforward. Read it, use the letters in the problem. Just remember, when you write your equal sign, not to forget to put in a constant of proportionality, or the m. Now you can try some of these problems and see how they go. In proportions, we often have to find what's called the mean proportional between two numbers. And the mean proportional is some special number that's between 4 and 100. So common sense when you're solving these, if you don't get something between the two numbers, you're probably goofed. So there's a special number between 4 and 100, so that when I set up the proportion 4 is to x, that same number works with x to 100. These two fractions are equal. They reduce to the same number in the end. How can I find that special number? There's only one of them between 4 and 100. Well, I could use trial and error. I could try 5, 6, 7 each time and solve and see which one works. But you guys know algebra, and we can use some algebra to solve this. Cross multiply. X squared equals 400. All right, how do I get x? Square root both sides. X equals square root of 4 times square root of 100. 2 times 10. Oh, x is 20. So that means 20 is that special number. 20 is the mean proportion between 4 and 100. Let's check it out, see what it looks like. So, 4 is to 20, as 20 is to 100. I could multiply this way and see, is 4 times 100 the same thing as 20 times 20? 400, 400. I checked it the same way I solved it. I like to check a second way. Not the way I solved it, but another way by reducing. Can I reduce this fraction? 1 over 5. Can I reduce this fraction? 2 over 10. Hey, 1 over 5. They reduce to the same number. If they reduce to the same number, you found the correct mean proportional between the pair of numbers. All right, let's try one more. Maybe you want to try this one, so stop the video. You try that one first, and then watch me and see if you get it right. This answer is not such a nice number, though. This came out to a nice 20. Sometimes they come out a little different, so you try it. So let's see how your work went on finding the proportion between 2 and 20. So hopefully you went 2 is to x, as x is to 20. Next step, x squared equals 40. Next step, square root of both sides. So square root of x squared, square root of 40. Oh, not so nice. X equals square root of 4 times square root of 10, 2 root 10. Are you telling me that the mean proportional between two numbers could be 2 root 10? Let's check it out. 2 is to 2 root 10, as 2 root 10 is to 20. How can I check it? I can cross multiply. 2 times 20, 40. 2 root 10 times 2 root 10. 2 root 10 times 2 root 10. Ooh. 4 root 100. 4 times 10, 40. I guess it worked. Remember the second way to check these? You could reduce them. This one reduces to, where can I write this? All right, let's write it right here. 1 over root 10. This one reduces to root 10 over 10. Are those the same? Remember, you're never supposed to leave a radical in the bottom. You know how to rationalize that? Multiply by root 10 over root 10. What's root 10 times root 10? 10. 1 times root 10. Oh yeah, they're the same. So there's two ways to check them. I like to check them by reducing because I'm using a different method, and that way I won't make the same mistake twice. So you should be all set with your homework. Good luck.